What is differentiation? It's probably something you've asked yourself if you're doing higher maths this year. So you get introduced to this topic and you get told a bunch of rules, but sometimes it's useful to talk about what is differentiation in the first place? What does it relate to? So generally speaking, you will speak about differentiation in terms of the rate of change, the gradient of a function, and we also talk about optimization as well. So if we talk about rate of change first, what we're thinking about is how is our function changing as x changes. So what we generally do is call dy by dx, which is our derivative, and we set that equal to our change in y over our change in x, which is the same as our gradient function from National 5, just written a little bit differently. What we can do to approximate the rate of change at a specific point is we can take these points closer and closer together, and then we end up getting our gradient at that specific value of x. We can also talk about it in terms of another variable. So say we want to talk about the rate of change of volume in a water tank. We can say that we start off with a specific volume of water, and then we have water flowing in and out, potentially at different rates. So to understand how the volume is changing over time, we can graph that function dv by dt, and that helps us better understand the situation. We also talk about the gradient of the function quite often, and you're expected in your higher to sketch the derivative of a function. So say we have this parabola here, which is a nice quadratic. We can see that we have this negative gradient to begin with, and so on our derivative, that corresponds to going underneath the x-axis, because that corresponds to negative values. We then reach this turning point where our gradient is technically 0, and so that is why our dy by dx is on the x-axis there, because that equals 0. We then have a positive gradient that shoots back up again, and so we're now above the x-axis. So it helps us better understand what our gradient of the function is at all of these different points. Last but not least, we have optimization, which, to be perfectly honest, most people do not love when it comes up in your exam. But it's a really nice, applicable way to think about how differentiation is used in real life. Say you're running a company and you want to figure out what's the best way to maximize your profits or potentially minimize your losses. What you can do is set up a nice equation, and you can think about where you have these stationary points. And that is your maximum and your minimum values.